Before February 24, 2022, the Russian Federation looked like it would deploy, or soon be able to field, some pretty formidable new weapons. In everything from 5th-generation fighter jets to modern tanks, to new body armor and even tsunami-causing nuclear torpedoes, there was enough hype to make even informed Western national security experts worry about what they were seeing. Little wonder that they believed Ukraine would fall in days in the months prior to the invasion. Those predictions did not turn out to be the case, and now 2 years later, Russia still finds itself fighting a war of attrition with no end in sight. In this video, we'll take a brief look at how Russia's military arsenal has failed to live up to the hype, and why it has failed, and even why some of the weapons Russia claims it's developing will likely not perform as advertised. If they can build them at all, that is. Russia has one aircraft carrier, the Admiral Kuznetsov. The Admiral Kuznetsov began its life in the 1980s and was commissioned in 1991, just before the Soviet Union's collapse. However, this carrier is not of the same quality as the US Navy's aircraft carriers, which use a catapult system to rapidly launch their planes. Instead, it uses the STOBAR, Short Takeoff Barrier Arrested Recovery system, which makes its planes far slower to launch than the American Nimitz and Ford-class carriers, or China's Fujian. The Admiral Kuznetsov has also been plagued with problems, with frequent deadly accidents. The ship has been under repairs since 2018, with one delay piled onto another. It was originally supposed to return to service in 2021, but obviously that did not work out as planned. The ship is finally supposed to return to service in 2024, but that date is still questionable. Corruption has also plagued Admiral Kuznetsov's repairs. 3 years ago, the director of the Murmansk shipyard was arrested on suspicion of embezzling rubles, the equivalent of $600,000. Such corruption is rampant in the Russian military and has long proven a problem with weapons development, logistics, and maintenance. The Admiral Kuznetsov saga is a good way to start the video because it reveals deeper problems in the Russian Navy, which include outdated equipment, incompetence, and corruption, which have all played out in the war as seen in Ukraine's success against the Black Sea Fleet, despite having no navy of its own. Russia's surface navy is in poor shape in other ways. It is steadily retiring its Soviet-era ships and replacing them with lighter, less combat-worthy vessels. This process is slowly but surely causing the Russian Navy to lose its blue water capabilities and confining it closer to the coasts. One of the ways that Russia has attempted to mitigate this trend is through a new class of destroyer, the Lyda class. If completed, the Lyda-class destroyer could prove a formidable new addition to the Russian Navy. It would weigh 19,000 tons and be powered by nuclear propulsion, making it twice as large as the Soviet-era destroyers it would be replacing. It would even be larger than the 3 Slava-class cruisers in service with the Russian Navy. The ship's size would make it capable of supporting new weapons, such as the 3M22 Sirkon winged anti-ship hypersonic cruise missile, which is a naval version of Russia's S-500 air defense system. The Lyda class would also be able to field the Packet NK torpedo and Packet MTT anti-torpedo. The offensive version can hit targets up to 10 kilometers away, improving the range on Russia's previous torpedoes, with a much more accurate targeting system. If the Lyda and its classmates were to come online, it would be a big improvement over the Russian Navy's current ships. Unfortunately for Moscow, this new destroyer has suffered from numerous delays. The Lyda-class destroyer was first revealed in 2015, with Western experts seeing it as an attempted answer to the United States Zumwalt-class destroyers, then under construction. Unfortunately for Russia, these new destroyers have not taken to the sea. In fact, they have not even begun construction nearly 10 years later. Construction on the new class of destroyer was finally supposed to begin in 2023, but that year has now come and gone. The Lyda project was even dropped from the Kremlin's 2025 state armament program, which made foreign defense experts question its future. Russian sources claim that its being dropped from the state armament program did not mean that the Lyda had been cancelled, but rather that funding for it had been reduced. As of 2024, we cannot know when, if ever, construction will begin, and therefore that the Russian Navy will continue to get smaller and lighter as its older and heavier ships get retired. The problems for the Russian Navy go deeper than the surface vessels. Its underwater fleet is also aging, and its supposed newest and greatest submarine is also probably an item that owes its reputation more to advertising than performance. The Belgorod submarine, and particularly its Poseidon torpedo, are 2 other items of hype in the Russian Navy that don't seem to stand up to scrutiny. The Belgorod and Poseidon have often been items of fear in Western media and national security circles, which have nicknamed the former Russia's Doomsday Submarine. According to the Kremlin's hype, The submarine and its arsenal of smart drone Poseidon torpedoes can unleash a 100 megaton yield capable of creating radioactive tsunamis that would inundate coastal communities and make them unlivable. However, tests of the Poseidon have seemingly proven less than satisfactory. That shouldn't be too surprising, because for the Poseidon torpedo to work as the Russians claim, it would need to be able to house all of the equipment needed for a nuclear reactor to convert atomic fission into electricity and propulsive force, while ensuring negligible waste heat to avoid detection. It would also need the hardware to shield its sensitive electronics from the nuclear fission process. Unfortunately for Moscow, the torpedo is too small to do this, meaning that it's either an object of hype or Russian engineers have come upon a technological leap enabling exotic engineering methods. We'll let you decide which of the two scenarios is likelier. Meanwhile, even if the Poseidon's yield was 100 megatons, which it almost certainly is not, it would still not be large enough to generate the type of tsunamis the Russians claim it can. Instead, the likeliest scenario is a yield of about 1 to 2 megatons per torpedo, which would be enough to inundate a coastal area with dangerous radioactive waters but not create a tsunami. The Poseidon torpedo also faces engineering problems with its supposed speed. With a purported speed of 100 knots or 185 miles per hour, the Poseidon would be faster than all of the torpedoes in the arsenals of NATO member countries. However, if it were to go that fast, the torpedo would be easily detectable to sonar equipment, emitting noises far beyond the level of civilian ships that it would ordinarily try to hide behind. The torpedo would also have difficulty fulfilling its mission at the shallow depths which it would need to navigate in order to target coastal cities, which is its purported function, according to James Mack, a former nuclear and electronics technician with the United States Navy. If the Poseidon were to be traveling at its advertised speed of 100 knots or more in depths that shallow, it would not only be detectable because of the high heat it would generate, but also suffer from cavitation, the formation of vapor cavities in a liquid when it has been accelerated to high velocities. Cavitation can create shockwaves that damage machinery, meaning that the Russians have either compensated for this with unknown new engineering techniques and technology, or the claims of the Poseidon again do not stand up to scrutiny. This will be far from the only time in the video where this dilemma presents itself in relation to a Russian weapon system. There is also only one Belgorod submarine, meaning that it can easily be tracked by satellite surveillance when it needs to dock for upkeep. From this surveillance, intelligence analysts have a good chance of guessing its mission. International defense experts guessed just that when Belgorod conducted its exercises in the autumn of 2022, for example. We now journey from the sea to the skies and look at the Russian answer to the American 5th generation F-22 and F-35 fighter jets, the Su-57 Felon. To be fair, the Su-57 does have some impressive features, like its 3D thrust vectoring engines, climb rate of 64,000 feet per minute, 66,000-foot service ceiling, Mach 2 speed, and a range of 2,186 miles without refueling. In a plane versus plane battle, the Su-57 should be a capable opponent against any fighter plane on the planet. However, the Su-57 has a big drawback: its comparative lack of stealth. Aviation experts regard the Su-57 as being by far the least stealthy of the 5th generation fighters currently in service. For example, the F-22 Raptor is detectable at a range only under 10 miles, while the Su-57 would be detectable at a range of 35 miles. Its stealth features are also concentrated in the front of the plane, meaning that if it turns or maneuvers, it's far more detectable. Some aviation experts are even less kind and believe the Su-57's radar cross-section is similar to that of the F/A-18 Super Hornet, which is 1,000 times less stealthy than the F-35 Lightning II. Therefore, they say the Su-57 is not a true 5th generation fighter jet, but rather an advanced 4th generation one. The lack of stealth means that advanced radars from other fighter jets or air defense systems are capable of detecting the Su-57 and destroying it from long range. These weaknesses seem to be confirmed by the way Moscow has used the new Felons it has in service. The Su-57 has played little part in the war in Ukraine, as the Russian aerospace forces have refused to field it in Ukrainian airspace. Instead, it has only attacked targets at long range from within Russian airspace. The limited use of the Felon speaks volumes about the Russian brass's confidence in its stealth attributes, or lack thereof. It's also unlikely that the Russian military will be able to manufacture the Felon in the numbers needed to make it truly formidable. The Kremlin ordered 76 Su-57s in 2019. 22 are in service as of December 2023, after several years of delays. It's difficult to see how Russia will field the Su-57 in adequate numbers anytime soon, giving it limited effectiveness as a means of making war. Russia is more well known for its tanks than its planes. However, the newest Russian tank has even more problems than the Su-57. To be fair, the T-14 Armata does have significant improvements over the tanks Russia has usually fielded in Ukraine, the T-72, T-80 and T-90. These tanks have been lost in their thousands during the fighting in Ukraine, thanks to bad doctrine and their own design flaws. Because they do not segregate their ammunition magazines in a sealed compartment, they have often suffered from complete destruction with jack-in-the-box explosions. The T-14 Armata mitigates this flaw with a protective capsule, isolating the crew from their vehicle's ammunition magazine. The vehicle's profile adds further protection, as its low silhouette avoids exposure of its parts to enemy fire. The Armata's main weapon is a 125mm 2A82 1M smoothbore gun, which can fire related rounds and laser-guided missiles. This weapon would be a significant threat to the Western main battle tanks that Ukraine began fielding in large numbers last year. Unfortunately for Russia, this gun is not backward compatible with its older tanks, which means that only the Armata can field it, and that's a problem because there has never been a confirmed sighting of the T-14 in Ukraine. Russia has even fewer T-14 Armata tanks than it does Su-57 fighter jets. From its inception, the tank has been mired in production delays. When it publicly revealed the tank in June 2015, Moscow claimed it would field 2,300 of them by 2020. That obviously never happened. In 2021, Russia promised serial production, but that didn't happen either. To date, only about 20 prototypes have been built. The T-14's engine in particular has proven to be an item of difficulty to manufacture. Unlike most of Russia's tanks, the Armata uses a derivative of the German X-shaped Simmering SLA-16 engine, which was designated as the A853. However, this engine was not designed for a tank, but as a unit for compressor oil and gas pumping stations. Nevertheless, it was chosen as the basis for the Armata, and the tank was designed around this engine rather than the other way around. While it had attractive features, being smaller and more powerful, though heavier than the standard Russian tank engine, it never truly proved adequate, and the Armata cannot be resized to fit Russia's proven and reliable tank engine, the V92S2F. The problem has presented a sunk cost fallacy to the Russian brass, as it has been reluctant to start on a new tank, instead struggling to find a way to make the engine problems work for the Armata. Meanwhile, the electronics for the Armata's sensory and fire control systems are no longer as widely available due to the sanctions put in place as a result of its invasion of Ukraine. Indeed, there has not even been an assembly line built for the Armata, and all of the prototypes have been made by hand. Given all of these problems, don't expect to see the Armata fielded in large numbers, if at all, anytime soon. The lack of a modern tank is a big problem for Russia, because its current tanks have often found themselves outgunned on the battlefields of Ukraine, as well as lacking adequate protection. Russia's tanks lack the range of their Western rivals because they cannot raise their guns as high. For example, the T-90, Russia's latest tank before the Armata, can only raise its gun by 14 degrees, or lower it by 6 degrees. The Abrams, on the other hand, can raise its gun by 20 degrees and lower it by 9. The additional flexibility means that the Abrams can hit targets at longer ranges than the T-90 or the other tanks Russia can field in Ukraine in large numbers. The lack of gun mobility also makes the Russian tanks more vulnerable in urban combat than their American counterparts, as fighters can shoot down on them with anti-tank weapons from rooftops or high windows and leave the armor unable to retaliate. Russia learned this lesson the hard way in its wars in Chechnya around the turn of the millennium. Russia has been unable to modify its tanks since then, however, and has suffered from ambushes in the same way during the war in Ukraine. The combination of flaws in the ammunition storage and the lack of firepower and flexibility has left thousands of tanks destroyed in the war, and Russia cannot seem to mitigate this problem because it cannot manufacture the T-14 Armata in large enough numbers to change the situation. Russia could try to overcome these disadvantages with changes in doctrine, including deploying infantry and other units to better support its tanks in combined arms operations, but there is no indication that Russia has built a capacity to do so. Decades of Soviet deep battle doctrine and centuries of Russian reliance on mass to overwhelm an opponent, no matter the casualties, have proven too difficult for the Kremlin's military commanders to shake. Meanwhile, engineering problems apply not only to Russia's current military gear, but the ones it claims it has coming. For example, Russia's body armor has also been a subject of embarrassment. Many of Russia's soldiers, especially the conscripts Putin mobilized in the autumn of 2022, have lacked proper protection. Infamously, some Russian troops were issued airsoft versions of the Ratnik body armor. Despite its problems in this area, Russia has made some bold claims about what it has coming down the pike. Its next-generation Sotnik body armor, which it says will be able to stop a 50-caliber Browning machine gun round. The Sotnik armor is supposedly going to be made of polyethylene plastic fibers to keep its weight down. Polyethylene is effective against incoming rounds because as the material heats up from the energy transfer, the plastic melts, adhering to the bullet and slowing it down. The principle has proven effective in other body armor systems around the world, and indeed, if there is enough polyethylene, it could work in the same way against a 50 BMG round. However, a .50 BMG round transfers over 11,000 pounds of force onto its target, enough to punch holes through a cinder block wall. To say the least, it would require a lot of polyethylene to put a stop to a round this powerful. Even accounting for improved efficiency, it's hard to believe that a soldier wearing this sort of armor would be mobile on the battlefield. Russian engineers would have a very tough hill to climb if they wanted to design a polyethylene armor that would afford such protection against an incoming 50-caliber machine gun bullet and keep the wearer mobile. We should treat the Sotnik body armor with skepticism, to say the least. Another big example of engineering challenges built into Russia's future weapon systems comes with the 6th-generation fighter jet it supposedly has in the works, the MiG-41. According to the Kremlin, this jet will be the fastest aircraft in the world, with a cruising speed of Mach 4. If it works as Russia says, the fighter would also have a ceiling superior to any other aircraft at 85,000 feet. Unfortunately for Russia, the MiG-41 is almost certainly an example of a weapon that would never be able to work as it claims. If the MiG-41 were to fly at its cruising speed, let alone what it would reach with its afterburners, it would lose its stealth attributes. Supersonic flight creates high heat and friction. Such friction erodes the stealth materials that help to reduce the radar cross-sections of planes like the F-22 and F-35. Additionally, the heat signatures involved in such high-speed flight would make the MiG-41 easily visible to radar. Russian engineers would need to have exotic technology on their hands to mitigate such a weakness. Don't count on that. The MiG-41 is supposed to be an evolution of the MiG-31 Interceptor, which was designed to counter the American SR-71 Blackbird spy plane. It was built to reach speeds of Mach 2 for that purpose. The problem for Moscow is that an interceptor is a far different order of business than a 5th-generation fighter, let alone a 6th, and the SR-71 has been retired from the American air fleet since the 1990s. Why the Russians would choose to develop their 6th-generation fighter from an outdated concept is puzzling and suggests that even without the engineering challenges to get it to work as advertised, the MiG-41 could suffer from the same problems as the T-14 Armata, a frame built around a questionable concept. According to the Kremlin, the MiG-41 will have its maiden flight in 2025 and begin delivery in 2028. But given Russia's long delays in introducing new weapon systems or even repairing existing ones, we should take those claims with a heavy grain of salt, to say the least, even if everything else supposedly works. What do you think about these failures of Russian military engineering? What other weapon systems from Russia have proven not to live up to the hype? Don't forget to let us know in the comments. Also, don't forget to hit the like button and subscribe to the channel for more military analysis from military experts.